Good day, grade 10s. Welcome to the second part of the states of matter and the kinetic molecular theory. So let's get into it. So what does the kinetic molecular theory state? So the kinetic molecular states that all matter is composed of particles which have a certain amount of energy, which allows them to move at different speeds depending on the temperature or energy. Depending on the temperature or energy, there are spaces between the particles. So there are spaces between the particles. And also attractive forces between the particles. When they come close together. So this is what the kinetic molecular theory states. So the takeaway from this, the main component, it states that all matter is composed of particles which have a certain amount of energy which allows them to move at different speeds. So this is what we should know: different speeds depending on the temperature. There are spaces between the particles. So the spaces between the particles, and there are also attractive forces between the particles when they come close together. Very important to note that. So what does that mean? So we have a liquid, right? So we start with liquid. We were gonna start with a solid. So we know there are three states of matter, right? So we have solid, and then we have liquid, and then we have gas, right? And then we know in a solid the particles are packed closer together, right? And then we're going to describe this. And then in a solid we know that the particles are packed next to each other uniformly, so they show a pattern. And then in a liquid it will be different, obviously. We'll have this situation, and in a gas the particles are far from together, so we'll have that situation, right? So in a gas we'll have that situation. And then for solid we have low energy. So we have low energy. It means that the particles in a solid, the particles vibrate around a fixed point. And the reason why they vibrate is because they are close next to each other, so they just vibrate around each other, basically. So they just touch each other by vibrating around a fixed point, right? And then in a solid again, the spaces are very little. So there are very little spaces between the particles, very little spaces between the particles. So there are very little spaces between the particles. And we also have what? Because the particles are very close next to each other, the forces are very strong. So we have very strong forces. So we have very strong forces. And then a solid, the volume of a solid is fixed. So it has a fixed volume. It has a fixed volume. That is very important to remember. It has a fixed volume. And then also when the temperature of solids are increased, they become what? They become a liquid. So, and also if we increase the temperature of a solid, it becomes what? It can become a liquid. So this is it. So this is the characteristics of the solid, right? And then now we come to the liquid, the particles in a liquid. So for the particles in a liquid, we have the particles have more energy. So in a liquid, the particles have more energy than in solid. They have more energy than in solid, but less than in gas. So the energy is more because why? In a liquid, the particles are freely to sort of move more than they will do that in solids, right? So comparing liquid and solid is that in a liquid, the particles, they can move around more than when they are in solids. But when they are in gas phase, right, the particles are far from each other. So in a gas phase, obviously, they have more energy, right? And then now we have the second point is that the spaces are bigger. So bigger spaces between the particles. So bigger spaces than in solids. But smaller than in gases. Then the third, we have the forces between the particles. So we have weak forces than in solids, but stronger forces than in gases. Stronger forces than in gases, right? And then if we increase the temperature, a liquid can become a gas. So these are the characteristics. And then now we're going to talk about the gas phase. Then in the gas phase, the particles have high energy. So they are very energetic and they are constantly moving and are constantly in motion. and then there are large spaces between the particles. There are large spaces because large spaces between the particles. The spaces are large because of high energy. And then we have weak forces because of large distances between particles. Because of large distances between the particles, yeah, so you can see in the gas in that diagram that the distance between the particles is very large. So when the distance between the particles is very large, then we say that the substance is in the gas phase. The particles have high energy, they can move around faster, they are very energetic in a gas when the substance is in the gas phase, right? And then in terms of phase change, a gas, yeah, if we decrease temperature, a gas can become a liquid or a solid. So these are the characteristics of solid, liquid, and gas based on the kinetic molecular theory. So these characteristics that we have described here, they are all based on the kinetic molecular theory. So let me show it here. Based on the kinetic molecular theory. They are all based on the kinetic molecular theory. And then next, we have these few examples that we're going to do. We have example 1, and then in example 1, we are given melting points and boiling points of different substances, right? Now, the first question, give the state of matter that each element is in at room temperature. So in order to answer these questions, we need to know this. We need to know that if temperature is less than the melting point, then the substance is in the solid phase. Very important, right? The substance is in the solid phase. And if temperature is between melting point and boiling point, means the substance is in the liquid phase. Let me just do this so that we can track them. And then the third one is that if temperature is greater than boiling point, then substance is in the gas phase. The substance is in the gas phase. So it's very important to note that, right? And then now we're going to start with phosphorus. So what is phosphorus at room temperature? So at room temperature, then we are going to check what is the melting point of phosphorus. The melting point of phosphorus is 44, and then room temperature is 25 degrees, right? So 25 degrees Celsius is what is less than 44 degrees Celsius. So it means phosphorus, when it is at room temperature, is in the solid phase. So it's solid phase. And then now we come to copper. What is the melting point of copper? 1085. And then at room temperature we have 25 degrees is less than 1085 degrees Celsius, which is the melting point of copper. It means copper is in the solid phase when it's at room temperature. Next one is bromine. Bromine, the melting point of bromine is -7. So we check what is the room temperature. Room temperature is 25 degrees. So the melting point of bromine is -7. So it means that 25 degrees is between, so we have -7 degrees Celsius is less than what? Is less than 25 degrees Celsius. And then what is the boiling point of bromine? Is 59. So we have 59 degrees Celsius. So do you see that room temperature is between boiling point and is between melting point and boiling point? So in this case, it means that bromine is in the liquid phase. So bromine is in the liquid phase. Why? Because of the room temperature. Room temperature is between melting point and boiling point. This is according to the second point that I've shown, that if the temperature is between melting point and boiling point, the substance is in the liquid phase. And then next one is magnesium. What is the melting point of magnesium? So we can see there that magnesium is 650. So 25 degrees Celsius is less than 650 degrees Celsius. So magnesium is in the solid phase. It's in the solid phase. Magnesium exists as a solid at room temperature. And then chromium, what is the melting point? Is 1907. So we can see that 25 degrees Celsius is less than 1907 degrees Celsius. So chromium exists as a solid at room temperature. And then what about silver? The same thing. We see that the melting point of silver is 962. So 25 degrees Celsius is less than 962 degrees Celsius. So silver exists as a what? As a solid at room temperature. And then this is how we analyze and determine the substances, how they will exist at room temperature. Then example 2, we have the table here of different substances. So we are going to use the kinetic molecular theory in this case. So the first question says, use the kinetic molecular theory to help you complete the following sentence. Chlorine has stronger or weaker intermolecular forces between the particles than argon. So then here we have to check. So if we look at the melting point of chlorine and that of argon, what do we see? So we can see that chlorine has a higher melting point than what? Than argon. So chlorine has higher melting point than argon. So it means we need more energy. We need more energy to melt chlorine than to melt argon. Therefore, it means chlorine has stronger forces than argon. So chlorine has stronger forces than argon. So it means the correct answer is going to be what? The correct answer is going to be stronger here. So the correct answer is stronger. This answer here is the correct answer, which is stronger. So stronger. And then the second question, use the kinetic molecular theory to help you complete the following sentence. The particles of chlorine have more or less space between them than particles of copper at room temperature. Then we need to ask ourselves, chlorine exists as what at room temperature? So at room temperature, we can see that for chlorine, we can see that the melting point of chlorine is minus 102 degrees Celsius, and then it's less than 25 degrees Celsius, which is room temperature. And then the boiling point of chlorine is what? It's minus 34. Minus 34 is still below room temperature, meaning I have to cancel here and say this. So we can see that here we have this situation. The boiling point of chlorine is minus 34 degrees Celsius, and minus 34 degrees Celsius is less than 25 degrees Celsius. So it means at room temperature, chlorine exists as a gas. Why? Because of room temperature is greater than the boiling point of what? Of chlorine. So chlorine is a gas at room temperature. So therefore chlorine is a gas at room temperature. And then now we need to ask ourselves about copper. What about copper? So copper, the melting point of copper is 1085 degrees Celsius. So we can see that for copper, room temperature, which is 25 degrees Celsius, is less than the melting point of copper, which is 1085 degrees Celsius. So copper exists. Copper is a solid at room temperature. So copper is a solid at room temperature. So this means chlorine has more spaces. This means, let me write it the correct way. So this means the particles that make chlorine. This means the space between the particles of chlorine this means the space between the particles of chlorine is larger than in copper since chlorine is gas and copper is solid at room temperature. So it means the correct answer here will be particles of chlorine have more space between them than particles of copper at room temperature. So the correct answer here is going to be more. Then the last question, which is the third question, says that use the kinetic molecular theory to help you complete the following sentence. The particles of liquid bromine have more or less kinetic energy than particles of liquid aluminium. So we need to ask ourselves then. So if we look at the table that we are given right there, bromine is in the liquid state when it's between -7 degrees Celsius and 59 degrees Celsius. So bromine is a liquid, exists as a liquid, right? Remember, a liquid exists between what? Melting point and boiling point. So it exists as a liquid when its temperature exists between -7 degrees Celsius and 59 degrees Celsius. Then now we're going to check for aluminium. Aluminium is a liquid. It exists as a liquid when its temperature is between what? When its temperature is between 660 degrees Celsius and 2470 degrees Celsius. So from here you can see that bromine is actually colder than aluminium. So can you see? So therefore bromine liquid is colder than aluminium liquid. Because of bromine liquid is colder than aluminium liquid according to the comparison, right? It means the particles in bromine, they have less kinetic energy. So the particles in bromine are not active. They have less kinetic energy. The particles in bromine liquid, let's specify, they have less kinetic energy than in aluminum liquid. So it means the answer here will be what? Particles of liquid bromine have less kinetic energy than particles of liquid aluminium. And the reason is that when we compare the temperature at which bromine will exist as a liquid, when we compare the temperature to that of aluminium, bromine will be much colder than aluminium when we compare, because bromine exists as a liquid between -7 degrees Celsius and 59 degrees Celsius, while aluminium exists as a liquid between 660 degrees Celsius and 2470 degrees Celsius. And you can see that 660 is way bigger than 59 degrees Celsius. So you can see that is the reason why we say bromine is more colder than aluminium when we compare them, right? And then this is how we analyze the whole questions. And yeah, so the kinetic molecular theory chapter is an interesting chapter and is not that complicated. With much practice you can ace it with 100%. So bye for now, see you next time.